in online classes, work is a bit slow. So whatever I teach in 1 hour in offline batch, that's the same content has to be covered in online batch. For that, maybe 10 minutes extra will be required. So you should be prepared that maybe it goes up to 1 hour, 10 minutes, right? Right now, solutions. There'll be a lot of introductory part in the chapter. Rarely questions are asked from the introductory part, but sometimes, of course, 1 mark question can be asked in CBSE. Right on. A solution is, now write, and write. A solution is a homogeneous mixture of two or more substances mixed together in any ratio by mass. Mixed together in any ratio by mass. Substances which are mixed to prepare a solution are called components of the solution. A solution made up of two components is called a binary solution. Is called a binary solution. Like if you dissolve sodium chloride in water, we call it a binary solution. Similarly, if there are three components, then we call it a ternary solution. Like if it dissolves sugar and salt in water. So there are three substances, three components, we'll call it a ternary solution. Continue. Size of solute particles is less than 1 nanometer, due to which solute and solvent cannot be separated by filtration or centrifugation. Centrifugation is the process which is based on centrifugal force. So we cannot separate solute and solvent by centrifugation or by filtration, because the pore size of filter paper is bigger than 1 nanometer. So solute particles will pass through these pores. Next paragraph. Properties of a solution depend on its concentration. For example, a 1 ppm solution of fluoride ions, F- ions, fluoride ions, prevents tooth decay. You might have heard some toothpaste ad that so-and-so toothpaste contains fluoride ions. So these fluoride ions will prevent tooth decay, provided concentration of fluoride ions is 1 nanometer, 1 ppm. However, if the concentration is 1.5 ppm, it develops colored spots on teeth. So if someone has the feeling that more the concentration of fluoride ions will be better for teeth, no. If the concentration is 1.5 ppm, then some black spots will be developed on teeth. A still higher concentration is poisonous. For example, NaF, sodium fluoride, is used as a rat poison. Next paragraph. See, every paragraph has a specific content. So make paragraphs as I say. So next paragraph. Out of two components of a binary solution, one is solute and the other is solvent, which is decided as follows. So there are three ways to decide which of the two components is solute or the solvent. Number one, if water is one of the components, solutions are called aqueous solutions, and water is considered.
Hello. Sorry, sir. Could you repeat that?
If if water is one of the components, then solutions are called aqueous solutions, because in many numericals it will be mentioned aqueous solution. So it is understood that water is the solvent. Aqueous solutions, and water is considered as a solvent. Water is called universal solvent because it dissolves maximum number of solutes in it. Number two, please write each and everything, because if your notes are complete, you will not have to refer to any book. Second point, that component whose physical state is same as the physical state of solution is called solvent. For example, copy this example from the board. For example, iodine is solid, alcohol is liquid. When we mix these two, we get solution. And this solution is in the liquid state. Since physical state of solution and alcohol is same, it means alcohol will be called solvent. So understood that iodine will be solute. Does anyone know what is this solution? What the solution is called? Anyone?
Tincture of iodine.
Sorry?
Tincture of iodine.
Yes, this is tincture of iodine. It's applied on wounds. This is tincture of iodine. Number three, third case. If none or both the components are in the same physical state as the solution, then that component which is present in more quantity by moles. More quantity by moles. Underline by moles, it's not by mass, is considered as solvent. For example, nitrogen is gas, oxygen is gas, and their solution, you can say air, is also gas. Now, out of these two components, the one which is present in more quantity by moles is considered as solvent. If I say this is 10 moles, this is 12 moles, then this will be solvent. So both are in the same physical state as solution. Second example, sodium is solid, potassium is solid, their solution is liquid. Solution of metals is what? Nothing but an alloy. Alloys are solutions. None of the two components is in the same physical state as the final solution. In this case also, the one which is present in more quantity by number of moles will be considered as solvent. If I say 6 moles, 5 moles, this will be solvent. One more example. Alcohol, liquid, plus water, liquid. Solution is also liquid. It is similar example as the first example, but be careful. Let us say this is 5 moles and this is 4 moles. Which of the two is solvent?
Alcohol.
No. In this case, remember, if water is one of the components, then according to first point, water will always be considered as solvent irrespective of its quantity. So although this is less number of moles compared to alcohol, this will be solvent. Okay. Next topic. Classification of solutions. Classification of solutions. We'll consider 4 types of classifications. Number 1. All this is introductory part, not very important from examination point of view. Let me tell you. Number 1, based on physical state, solutions can be classified. Solutions can be classified into A, solid solutions, for example, alloys, physical states may be solid, liquid, or gaseous state. Solid solutions, for example, alloys. Liquid solutions, for example, NaCl plus water. Ultimately, solution obtained is in the liquid state. C, gaseous solutions, for example, air. Number 2, saturated and unsaturated solutions. I think I need not dictate anything about it. You know very well, saturated and unsaturated, which is something which will never be asked. Saturated means in which no more solute can be dissolved at a particular temperature. It's important to mention that at a particular temperature. It means if we can dissolve a little more quantity of solute, it is unsaturated solution. Now, generally what happens is when we increase temperature, generally not always, when we increase temperature, solubility increases. Or we can say a saturated solution becomes unsaturated at a higher temperature. So no details. I think there's no need to write anything. Number 3, dilute and concentrated solutions. Dilute and concentrated solutions. See, let us say we consider 3 students. In a particular test, one child scores 95% marks, second 96, and third child scores 97% marks. But I feel all the 3 are brilliant children, but I can still say that first child is little duffer compared to second. Second is duffer compared to third, although they are not, right? These are comparative terms. I can say compared to second child, first is little weak in studies. Similarly, dilute and concentrated solution, these are comparative terms. I can say this solution is dilute compared to this, or I can say this solution is concentrated compared to this solution. So just write one sentence. These are comparative terms. These are comparative terms based on the ratio of amount of solute to amount of solvent. Amount of solute to amount of solvent. For example, 1 gram NaCl dissolved in 1 liter water is a dilute solution compared to 1.1 gram NaCl dissolved in 1 liter of water. 1 liter of water. See, both appear to be dilute solutions. Even if you dissolve 1.1 gram of sodium chloride in water and taste it, you'll probably not feel that sodium chloride has been dissolved. But still, this second solution is concentrated compared to the first solution, right? These are comparative terms. Now we are coming to the last classification, number 4. This 4th classification will be important in CBSE. Once in a while, question is asked. Number 4. Based on physical states of solute and solvent, solutions can be classified into 9 categories. This you please write in tabular form. Solute, solvent. Example. Solid, liquid, gas, dissolved in solid, solid, solid. It means I can say solid dissolved in a solid, liquid dissolved in a solid, gas dissolved in a solid. Right? So like this, there will be 9 categories. Right on. Solid in a solid. Example, alloys. Liquid in a solid. For example, amalgams. You know, amalgams are alloys in which one of the metals is mercury. Third, gas in a solid. A very important reducing agent used in organic chemistry. This is hydrogen oblique palladium. In this, palladium is used in the form of fine powder so that hydrogen and palladium metal, they form a homogeneous mixture. Next, liquid, liquid, liquid. Solid in a liquid, NaCl plus water. I hope you're writing each and everything. Liquid in liquid, alcohol plus water. Gas in a liquid, soft drinks, aerated water. Next, solid in a gas. This is an important category, market. Iodine vapors. You know, iodine undergoes sublimation. When iodine sublimes, very small particles of solid iodine, they remain suspended in air. So this forms a homogeneous mixture. Liquid in a gas, water vapors in atmosphere. Water vapors in atmosphere. And last category is gas in a gas, air. Mixture of any two or more gases will always be a solution. So children, this was the introductory part. Now we start with the main chapter. Heading is concentration terms. Concentration terms. If you remember, in 11th standard, you studied about 4 concentration terms: molarity, molality, mole fraction, and mass fraction. All those 4 will be repeated, plus many more will be added in 12th standard. All are numerical based concentration terms or topics. Number 1, mass fraction. Mass fraction. Children, please develop a habit that you underline the heading, because this heading generally I'll be using this heading as a part of the sentence. So write down mass fraction of a component. Mass fraction of a component is the ratio of mass of that component to total mass of the solution. Total mass of the solution. Now I'm giving the formula how to calculate mass fraction. M subscript component means mass fraction of component is equal to weight of component divided by weight of solution. And also please enclose all formulas in square box in a box so that these are highlighted. Now about this mass fraction, write down always less than 1, independent of temperature. That is, if you change temperature, mass fraction will not change. And third point, sum of mass fractions of all the components is 1. Sum of the mass fractions of all the components is 1. Now I'm sharing one numerical on mass fraction. First I'm sharing on WhatsApp, and then I'll also share on chat box. I'm not used to it, in fact, that's the problem. Yes, here it goes. So this is the numerical, we'll solve it. So numerical is 0.5 mole of NaOH within brackets the molecular weight is dissolved in 10 moles of water. Calculate mass fraction of NaOH in the solution. Very, very simple. Weight of NaOH will be 0.5 into molecular weight, 20 grams. Weight of water will be 10 moles into 18. Weight of water is 180 grams. Mass fraction of NaOH will be weight of NaOH divided by weight of solution. Weight of solution is 20 plus 180. So the answer is 0.1. So as I said, value of mass fraction will always be less than 1. And since sum of the mass fractions is 1, if you have to calculate mass fraction of the other component, you need not calculate again. 1 minus 0.1 will be the mass fraction of water. Number 2, second concentration term. Mass percent. Mass percent. Within brackets, W/W percent. W/W percent means weight/weight, means we'll consider only masses of solute as well as solvent. Right, of a component, mass percent of a component is the number of grams of that component in 100 grams of the solution. Now write down the formula. Component percent is equal to weight of component divided by weight of solution into 100. Weight of component divided by weight of solution multiplied by 100. Now, what is this? This is nothing but mass fraction. So I can say mass fraction of the component multiplied by 100. Now for this, write down always less than 100. Always less than 100. Independent of temperature. Independent of temperature. And third point, assume sum of mass percents of all the components is equal to 100. Is equal to 100. Now, based on this, I'm sharing a numerical. See, while teaching this chapter, we'll be solving roughly 30 numericals in the class itself, apart from assignments which I'll be sharing later. You can see the statement on WhatsApp or chat box. Numerical is 0.25 mole of NaOH is dissolved in 40 grams of water. Calculate mass percent of water in the solution. So weight of NaOH, 0.25 into 40, 10 grams. Mass percent of water is equal to weight of water divided by weight of solution. Weight of solution will be 50 into 100. 80%. And please don't have the feeling that you'll get such simple numericals in JEE Mains or board. Even in board, this type of simple numericals are not asked. I'm just telling you how to use the formula. You'll have many difficult numericals to solve. Number 3, third concentration term, volume percent. Volume percent. Within brackets, V/V percent. It means in this case, we'll consider volumes of both the components rather than their masses. And this is used when solute as well as solvent are liquids or gases. Liquids or gases. volume percent of a component is the number of parts by volume of that component present in 100 parts of the solution. Now write down the formula. Component percent V by V. The only difference is in place of masses, now we'll take volumes, is equal to volume of component divided by volume of solution into 100. For this, we'll take up a numerical later on. Right on next, fourth concentration term. Naturally, since volume is involved, this will be temperature dependent. This will vary with temperature. Next is mass volume percent. W/V percent. In this case, we take mass of solute and volume of solution. Okay, volume of solvent nahi, volume of solution. Whereas W is weight of solute. That it is the mass of solute in grams present in 100 cc of the solution, cc milliliters of the solution. This unit is used in pharmacy. If you have a bottle of some liquid medicine syrup at home, you can check that the composition is written on that bottle, name of the medicine. After that, at the end, on the extreme right, it will be written 1% within brackets W/V. It means 100 milliliters of that syrup contains so many grams of that medicine dissolved in it. Formula. Component percent W/V is equal to weight of solute divided by volume of solution into 100. Remember, weight will always be taken in grams. In case we are using any other unit, then I'll specify. Like in this case, weight understood, this will be in grams. Volume of solution will be in cc or milliliters. Now I'll share one numerical. Both terms will be used here. Wait a minute. In fact, it's easy for me to share on WhatsApp rather than chat box. Now check this numerical. This has 3 parts. (36.8). Wait. Yes, 36.8 cc of glycerol. Glycerol is glycerine. Density is 1.25 gram per cc. Is dissolved in water to prepare 200 cc solution whose density is 1.05 gram per cc. In the solution, calculate V/V percent of glycerine. This one is very easy. A part, glycerine, V/V percent will be volume of glycerine 36.8 divided by volume of solution 200 into 100. This will come out to, let me tell you, 18.4. volume of glycerine divided by volume of solution into 100. Second part, W/W percent of water. Now for B part, we need weight of solution. 200 multiplied by density of solution. This is 1.05. So weight of the solution is 210 grams. Then weight of glycerine. This is 36.8 cc multiplied by density. So weight of glycerine is, let me tell you, this is 46 grams. Now, water percent. Water percent by weight will be weight of water 46 divided by weight of solution 210 into 100. This is the second answer. Wait a minute, answer is 7. No.
Sir, we are doing weight of glycerine upon weight of solution.
Sorry?
So that is weight of glycerine upon weight of solution.
Oh yes, we have to calculate the weight percent of water, 210. 210 divided by no, wait. Water percent will be weight of water. Weight of water will be 210 minus 46. Right? This is weight of water divided by weight of solution in 200. Is that correct now? So this you can calculate. I think this should be 78.1%. Solution minus solute is weight of solvent, that is water. So water divided by solution into 100. Third part is weight by volume percent of glycerine. Weight of glycerine 46, volume of solution 200 into 100, 23%. So these are three answers of three parts. Right. Now coming to next concentration term, mole fraction. This is something studied in 11th standard also, mole fraction. That of a component is the ratio of number of moles of that component to to total number of moles of all the components in the solution. Now, formula. I hope you remember this symbol is not X, looks like X. This is chi. Chi component, that is mole fraction of the component, is equal to number of moles of that component. N stand for number of moles, divided by N1 plus N2 plus so on. So denominator is sum of the number of moles of all the components present in the solution. Now for this, write down always less than 1, independent of temperature, less than 1, independent of temperature, and sum of mole fractions of all the components is 1. Now, one simple numerical on this. Yes. 300 grams of urea is dissolved in water to prepare 2010 grams of water solution. Calculate mole fraction of urea in the solution. Number of moles of urea, 300 divided by molecular weight, 5 moles. Number of moles of water, weight of solution minus weight of urea is weight of water. So solution minus 300 divided by 80. This will be 95 moles. So 95 moles of water, 5 moles of urea. So mole fraction of urea will be 5 divided by 100, 0.05. Next concentration term, number 6. Now, this 6th concentration term is not a part of your CBSE syllabus. So like this, I'll keep on telling you time to time that if this is not a part of the syllabus, you can mark in your notes when you're writing. Next is mole percent. Mole percent of a component in the solution is the number of moles of that component, present in 100 moles of all the components in the solution. Write the formula. Mole percent is equal to number of moles of the component divided by denominator is sum of the number of moles of all the components multiplied by 100. It means this is nothing but mole fraction into 100. See, if you are given mole percent, divide by 100, it becomes mole fraction, and mole fraction is a widely used term in this chapter. Widely used. Next, 7th concentration term. Molarity. Molarity, capital M. See, I could save time by sharing numericals on WhatsApp or chat box. If I keep on dictating these numericals, then it will take time. Okay, molarity. It is the number of moles of solute present in 1 liter of the solution. Present in 1 liter of the solution. Write the formula. Symbol for molarity, you know, is capital M is equal to. Now, in this chapter, we'll use symbol A for solvent and B for solute. Right? In the entire chapter, A will be used for solvent, B for solute. So molarity is equal to WB. WB means weight of solute divided by MB. MB means molecular weight of solute into 1000 divided by V solution means volume of solution. This volume of solution is taken in milliliters, right? If you take volume of solution in liters, then numerator will be 1. It's better you remember one formula rather than more than one formula for the same concentration term. What is this? This is nothing but NB, means number of moles of solute. See, if temperature increases, volume will increase. And if volume increases, molarity will decrease. They are labeled inversely proportional to temperature. Inversely proportional to temperature. I'm sharing one numerical. Somebody please solve and answer before I start solving. Yes, the numerical is 6.1 grams of benzoic acid is dissolved in 169.9 grams of benzene. Density of the resulting solution is 0.88 gram per cc. Calculate molarity of the solution. We are given density of the solution and we are given masses of solute and solvent. So weight of solution will be sum of the masses of solute and solvent. So it will be 6.1 plus 169.9. So many grams is the mass of solution divided by density of the solution. So volume of solution is 200 cc. Now remaining part is very easy. So molarity will be weight of solute divided by molecular weight of benzoic acid 122 into 1000 divided by volume of solution. Answer will be
0.025.
yes, 0.25, and we'll pronounce it molar, M-O-L-A-R, molar. Now further in molarities, let us say we have a solution, we add some more amount of solvent to it, it will be diluted. After dilution, what is the molarity of the diluted solution? How do we calculate that? Second part we are going to take up, that if we mix two or more solutions of the same solute, then how do we calculate molarity of the resulting solution? These two will be part of this molarity only. Next paragraph. If a solution is diluted by the addition of some more amount of solvent, then molarity of the diluted solution can be calculated by using the formula M1V1 is equal to M2V2. One side is initial molarity and initial volume. The other side is final molarity and final volume of the solution. I'm sharing one numerical. I I expect you'll be able to solve it. Check your WhatsApp messages there. Yes, I'm waiting for the answer. Solve and tell me the answer.
3.
3.
3 molarity.
3.
3 is wrong.
3 molar.
3 molar is wrong.
3 molarity.
Molarity will be 2. Molarity will be 2. Look here, कैसे? 2 liters
Sorry,
of
sir.
Ah,
Sir, just realized, sorry.
Oh,
right.
I saw it later.
In the exam, you'll get only one chance. Once you submit your answer sheet, then it's gone. You can't make any change. Then you can't say sorry. Then it's gone. Initial molarity is 6. Initial volume 2. Final molarity we have to calculate. Final volume is not 4. Initial volume was 2. 4 more liters of water has been added. So final volume is 6. So it will be 2 molar. Right? Units of volume on both the sides should be same. Liter, cc. It's your choice, but volume units of volume should be same. Next paragraph. If two or more solutions of the same solute are mixed together, then molarity of the resulting solution can be calculated by using the formula M1V1 plus M2V2 plus so on is equal to M final V final. M1V1, M2V2, M3V3, these are molarity and volumes of solutions which have been mixed together. And M final V final is the final molarity, final volume. This numerical, please, you are on your own. I want correct answer. Make sure volume, units of volume should be same on both the sides. That is something important. Yes. Right. This is the last for today. And tell me the answer. Many of these concentration terms you probably studied in 11th standard also. So may not be very new for you. Yes, waiting for the answer.
Is it 1.2?
Okay, let me give you
0.8.
one. How much?
0.8 M.
Yes, that is correct. Now, for this type of numericals, listen to me very carefully. Let us say we have 2 cups of coffee. In 1 cup, the concentration of sugar is less. In the other, it is too high. I want coffee with an intermediate concentration of sugar. So what I can do is I mix both. The final concentration of sugar in the coffee will be more than the one which was dilute, means had less sugar. and less than the one which had more quantity of sugar. So keep in mind, your answer will be in between two molarities of solutions which have been mixed together. One is 0.7 molar, the other is 1.2 molar. It means answer should be more than 0.7, less than 1.2. Keep that in mind. 0.8 molar is correct. I'll solve it for you. Molarity 0.7, volume 1200 cc, milliliters. Second solution, 1.2 molar, volume is 300. Final molarity we have to calculate. Final volume will be this plus this, 1500. So answer will be 0.8 molar. Right, children? Now, I'll repeat for the last time now. Next time onwards, we'll start dotted time. I'll share the link as I did today, roughly 5 minutes before we start the class. I didn't know that we have to share the share the passcode also. I'll do that also in future. I'll start teaching dot at the scheduled time, right? Dot at time, irrespective of how many children have joined, because time is very important, precious. In case you have any doubt during the class and you are hesitant in asking in front of many children, remember you are not seeing the face of each other, you can ask. But still, if you don't want to ask during the class, you can call me any number of times. But please make sure you do not call me on the same day, because I get over with your class around 9:45 or Saturday will be 10:15. After that, I want to take rest. But from 5 in the morning onwards, you can call anytime, right? And it's my habit that if you call me and I do not pick up your class, I'll call you back. You need not call me again. I'll call you back myself, right? Right, children? That's all for today.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye,
Thank
sir.
you, sir.
Thank you, sir.